Let's revisit our video game console analogy of the Polkadot validator design. This video game console is capable of plugging in multiple games at a time. We learned that Polkadot Wasm runtime, which is around 1 megabyte, is plugged into every Polkadot node. Now, to become a para-validator of a specific parachain, the Polkadot node software also plugs in the specific parachain's runtime Wasm. Parachains need to register their Wasm runtimes with Polkadot as a prerequisite before launching. Parachain runtime upgrades will also need to be coordinated with the Polkadot relay chain so that the Polkadot network always has access to the latest Parachain runtime Wasm. Let's look at all of this from the Parachain perspective. Basically, a Parachain tells Polkadot that, hey, here is the rulebook and here are the transactions that my user submitted. Please use the rulebook to process the transaction. The parachain is going to execute these transactions as well and record them in its own blockchain, but will be waiting for the green signal from the Polkadot relay chain on whether that particular block consists of transactions that are all valid. Let me summarize the path of a parachain block. The parachain network maintains its own blockchain and state. It has its own nodes, which are called collators. The parachain is free to choose the mechanism for selecting a parachain block author. Some parachains use round-robin method, and some parachains use stake-based weights to decide which collator will be authoring the next block. Actually, a parachain can run successfully even with one collator. With that background information, let's see the parachain protocol in action. A parachain selects a collator to author a block and submit it to the relay chain. Polkadot shuffles and assigns a validator set to the respective parachain. Both validators and the collator open connections. The parachain submits the list of transactions as well as the state proofs packaged into a proof of validity block, or simply called POV block. We learned before that it is unnecessary to share the whole state of the parachain, and instead you can just share the state Merkle root as well as the hashes with the changes captured. This saves a lot of network bandwidth as well as storage space. The Polkadot validator processes the POV block from the parachain, and if everything goes well, the validator will back it saying the parachain block is valid. Alright, now the Polkadot validator distributes the POV block of the parachain across the Polkadot network using the erasure coding that we learned earlier in the course. And that data is made available for around 24 hours. This POV block data may be requested by a broader set of validators in case of disputes. If there are no disputes and the approval checks are successful, the POV data is discarded after 24 hours from the Polkadot network. This ensures that the Polkadot network does not get bloated and the data is redundant anyways, as it is already stored on the parachain's blockchain. This is visualized very well in the video illustration by Nibblebits. The collators on the parachain package the transactions into a block and add it to their blockchain, and also share the corresponding POV block to the set of Polkadot validators to validate. The Polkadot validators, upon successful validation, produce these small candidate receipts that are stored on the relay chain blocks. A relay chain block can contain candidate receipts of multiple parachain POVs. These blocks are finalized by Grandpa, that is actually shooting these laser beams on the blocks it deems final. Once the relay chain block with the candidate receipt of the parachain POV block is finalized, the parachain which is listening to the relay chain deems that specific block on its blockchain to be final. In a way, the finality on the relay chain and the parachain blocks are entangled, which is beautifully visualized in the scene that cuts to the relay chain and parachain, showing the entanglement of their block finality. Overall, Polkadot processes the transactions on its relay chain as well as its parachains. Hence, the transactions per second metric should accurately reflect this. With execution sharding, Polkadot indeed achieves scalability and is ready for applications that can harness this.